Python peeps and robot royalty, this is Prof G, and normally we don't want to put a bug in our program, but we're going to work with the Mosquitto MQTT service. We're going to set up a Mosquitto broker and a client service on our Pi, so that in the next video, we can use an app to publish requests to our Pi that'll control our robot. Now, this video is part of the CircuitPython series that my students are using as part of their physical computing course. They're building Raspberry Pi-based robots that they control through CircuitPython. Now, we'll install the Mosquitto and Paho MQTT software on our Pi. We'll configure Mosquitto for anonymous access. At the time that I recorded this video, I couldn't find any video tutorials that showed how to do this, set up the anonymous access, so hopefully this will be useful for others. We'll also add and test CircuitPython code on our Pi that will act as a subscriber that receives publish commands sent to Mosquitto, and we'll set up system control commands so that the Mosquitto server first and then our control PyBot program will run automatically when we start up our Pi so that we don't have to log into the Pi to begin using it as a robot. So let's roll! So friends, this is a video that's pretty specific to my students because they are building a robot using their Raspberry Pi and Adafruit Cricket hats, and they're going to control this with a free iOS app that I've got in the App Store. They're using this robot kit with DC motors that you can get from Adafruit, a Raspberry Pi. My students are using a 3A+. Just about any Raspberry Pi that has Wi-Fi capability can do, although if you want to play audio, it's going to be a little bit harder if you have a Raspberry Pi 0 series. They're also using Adafruit Crickets to power the motors on their Pi. They'll power the Pi remotely using a cell phone battery charger. The Cricket and the motors are going to be powered by this 3AA battery pack. The bot's going to play sound through a hamburger speaker that is attached to the standard audio jack that plugs into the Raspberry Pi 3s. Again, if you have a Raspberry Pi 0, that's going to be a little bit tougher because they don't have the standard audio jack. And they'll stick all their parts to the robot chassis by using Velcro tape. Now at this point, my students have also gone through all of our configuration videos, so they've got their Raspberry Pi set up on a Wi-Fi network. They've upgraded it. It's operating in headless mode, which means that they can communicate with their Pi using a terminal program and they don't need to be connected via keyboard or mouse. They've got CircuitPython installed on their Pis. They've already installed the Pygame library, which we use to play audio, and the Adafruit Cricket library, which we're going to use to control the motors. And if they're Mac users, they have Netatalk installed so they can copy files to the Pi. Windows users use WinSCP or the equivalent. And if you're following along with our class and need help with any of these steps, you can find more information in the playlist at bit.ly/raspberry-pi-tutorials. So if you've got all this material and you're set up there, we're ready to build. So we're going to be playing sound remotely, so let's be sure that your Pi has the same sound files that I'm using. So if you visit the URL bit.ly/circuitpython-school-tutorials, you can download the folder robot-sound. Just right-click and select downloads. I'm saving mine to the desktop. If you're not asked, you're probably saving yours to the downloads folder. If you need to, you can unzip the zip file and then throw the zip file into the trash. And then we want to copy this to the Pi directory on our Raspberry Pi. So I've got a Mac, and the way that I can do this is by first connecting to my Pi by selecting in the Finder the Go menu, then Connect to Server. Command K is the shortcut for this. And if you followed the Netatalk tutorial, you likely have the AFP command in here to connect to your Raspberry Pi. If not, you can go back and follow that tutorial and set everything up. My students, remember that you don't want to put .local at the end of this address if you're on the campus network, but do use .local if you are on a personal Wi-Fi network. Then, once you click on Connect, this loads the Pi's home directory. Again, you can see that I'm connected to my Pi. It has the host name profgpi, so make sure that you're in your Pi's home directory, and then just copy your robot sounds file into your Pi. Sometimes an error occurs the first time you try to copy over. If it does, just try it again. And if you open up the robot sounds folder, you should see a bunch of MP3 files in here labeled 0.mp3 to 12.mp3, plus a startup.wav file. That's a file that's going to play as soon as we start our control program. And now we're ready to install, configure, and test our other software. Now first, a little bit of background on how things are going to work and what we're going to be doing. Now our app and our bot are going to communicate with each other using a standard called MQTT. MQTT is a very popular communication standard. It was originally developed by IBM, but it's now open source, and MQTT stands for Message Queuing Telemetry Transport. It's simply a lightweight, meaning low overhead, way to send and receive messages. Because it's lightweight, it takes up very little space on devices, and it takes up very little bandwidth when messages are sent back and forth, so it's especially useful for the Internet of Things. Now, there are three important pieces for MQTT to work. There's a broker, there's one or more publishers, and there's one or more subscribers. Now, the idea behind this is that a subscriber tells the broker, hey, if any particular messages come in on a topic that I've subscribed to, send them my way. Now, the publisher can publish messages, and if they're on a topic that's been subscribed to, the broker will send out that published message to all of a topic subscribers. So to give an example, let's imagine we have a temperature sensor and we have a heater. Well, the heater might be a subscriber and say to the broker, hey, I'm going to subscribe to the topic temperature changes. Let me know when the temperature has changed. Now, if the temperature sensor publisher publishes a message that the temperature has changed, the broker looks at the incoming message, it checks its list of subscribers, and it sends a message on to anything that's subscribed to it. So the heater subscriber will receive any temperature updates, and the heater might have code on it that says, hey, if the temperature falls below a given value, turn the heater on. So think about this in terms of the Internet of Things. You might have sensors and devices that act as publishers and that detect things like, is a door open or has the sun gone down? And you might have a bunch of different subscribers, say an alarm, maybe a display that shows temperature and weather, maybe a lamp. And you could have multiple different subscribers to the same topic. So the heater might subscribe to temperature, and weather station might subscribe to temperature changes too. So when the change of temperature happens, it's published to the broker, and the broker says, hey, who subscribed to the temperature messages? Oh yeah, the heater subscribed, and the weather station subscribed too, so it can update its display. Now, the alarm might subscribe to messages about whether or not a door is open. If the door does open, the door publishes the door open message. It goes to the broker sees the alarm subscribe to the door open message, and the alarm might sound. And the lamp might subscribe to a message to be notified if the sun goes down. The light sensor publishes the message, the broker picks it up, sends a message onto the light which subscribed to this message, and depending on how the light was programmed, it might turn on or off. Now, what does this all mean for our robot project? Well, we need a broker, so we're going to download an open source broker program called Mosquitto, 2 T's for MQTT, get it? And also we need a subscriber, and what we'll do here is we'll write a Python program that acts as a subscriber, and we'll call that control-pybot.py. Now, both of these things are going to run on the Raspberry Pi. Normally, if we'd have multiple subscribing devices that a broker is sending messages to, then the broker would be on a separate device, sort of like a distribution hub for messages. But in our special robot case, we only have one subscriber, which is the Pi, which is running the robot. So we're going to run both the Mosquitto broker to collect the messages and the subscriber Python program on the Pi. Now, our iOS device has our app running, and that app is going to act as the publisher. So this is how it'll work. The Python program, which is a subscriber, is going to tell the Mosquitto program, which is the broker, hey, I want to subscribe to all the messages that are published on a topic called Pybot Move. Now, I could have created different topics for different categories, maybe one topic for movements and one for sounds, but to keep things simple, I only created one topic, Pybot Move, and that can contain messages that are either movements or sounds. So what are these messages? Well, as the programmer for this app, I decided that the messages were going to contain words, and those words were going to be forward, backward, left, right, and stop to correspond to directions. Or the words could be numbers, and those numbers correspond to the name of MP3 files that are in the robot sounds folder that we just copied over. Remember, those sounds are named from 0.mp3 to 12.mp3. So when we interact with the app, a message is published on the topic Pybot Move, and the Mosquitto broker is always listening for messages. It picks these up, and it sends them onto the Control Pybot program that's subscribed to these messages. Now, depending on the contents of the message, it'll either move the robot by triggering code to move the motors, or it'll play a sound. So for example, if we put our finger down on the up button in the app, as soon as we do that, the app sends a Pybot Move topic message with the contents forward to the broker. Now, the broker looks to see who subscribed to Pybot Move. It sees the Python program is subscribed, so the broker sends this Pybot Move message on with the contents forward to the Python program. The program receives the message, it takes a look at its contents, and I've written the code so that when it sees the word forward, it will throttle the motors forward with a positive value. Now, when the user lifts their finger from the arrow button in the app, a Pybot Move stop message is sent. The broker picks this up, it sends it over to the Python program subscriber, and the Python program sets the motor throttle value to 0, stopping the bot. Now, it'll do something similar if you push down on the button and then release for left, right, and back, and if a sound is tapped, the app publishes a Pybot Move message with the number corresponding to the sound file to play. The broker picks that up, forwards it onto the Python program, which sees the Python Move message is now a number, and it'll play the MP3 file that has the same name as that number.
Bro, that's totally cool.
Now that's it. Now you know how MQTT works. If you ever want to work on another messaging project using the Internet of Things, you got a nice head start. Now I've created a follow-along document where you can copy and paste the commands and avoid typos. You'll find that at gallagher.com/pybot-mqtt-setup. And we'll go through this document pretty quickly, but feel free to take your time and read everything if you'd like. Now, I'm assuming that you've already connected your Pi via the terminal program if you're using a Mac, or PuTTY if you're using Windows. If not, make sure that you're logged into your Pi. Then in your browser, copy this command here, sudo apt-get install mosquito clients, return to the browser, paste this into the prompt, press return, and I've already installed Mosquitto. You may be prompted to respond yes if you'd like to install and take up some space on your Pi. Absolutely type yes and press return, and in a few minutes Mosquitto should be installed. Next, return to the browser and copy this command, sudo pip install paho-mqtt, then paste this into the terminal at the prompt and press return. Say yes if asked to approve any installation. Paho MQTT will allow us to access MQTT using Python. Next, we copy this line here, systemctl is-active Mosquitto, again with 2 T's. Now this will just make sure that the Mosquitto broker program is running, paste it in at the prompt, press return, and you should see message confirming active. Next, we want to configure the Mosquitto broker to accept anonymous connections, and we're going to do this because our app isn't set up to log into Mosquitto with a username and password. Now normally in Internet of Things projects, when a broker is going to be running all the time, you do want to add that extra security. And in the last version of Mosquitto, the developers actually required you to explicitly allow anonymous connections. It used to happen by default. But since our robot is only on when we're using it, we'll assume that the security risk is low, and we also want to simplify implementation and setup. But if you need more security, feel free to explore the Mosquitto documentation online. And now, as mentioned, we're going to allow anonymous users to connect to our broker, and that'll let us use the app that I've created. So let's highlight this line here. This line should have a sudo in front of it. As I record this video, I'm actually having problems with my website. I can't update this small change. So if you don't see sudo in front of it, then remember we've got to add this. So whatever you see here, sudo or no sudo, copy this whole statement, return to the terminal. If you don't have sudo in there, type in sudo space and then paste it in. Otherwise, paste it all in. The command should look like this, sudo space nano space / etc / mosquitto / conf.d / connect.d. And that's going to start nano and create a file in a specific location with a specific name that Mosquitto will check when it runs. And if it sees the information we're about to enter in here, it will allow anonymous users to connect, like our app. So there's nothing in this file right away, but let's return to the browser. We're going to highlight and copy these 2 lines, listener 1883 and allow anonymous true. Return to the terminal, paste these in. These commands will now allow our app to connect. So let's exit nano, control X, say Y, press return, and we're good. And we've just updated Mosquitto so that it'll allow our app to connect. Next, we'll enter a command to get Mosquitto to run whenever we turn on our Pi, and we want our robot to run without requiring us to log in. So first find and copy this line, sudo systemctl enable mosquitto.service, then return to the prompt and paste that in, press return. It'll take a few seconds for that to set up. And then we'll copy this command to stop our Pi, sudo halt, paste it in, press return. And now turn off your Pi, also unplug the battery pack from your Cricut, and make sure that there's no extra power coming to your Pi. And also, if you haven't done so, make sure that you've plugged your speakers back into your Pi, turn the speakers on, make sure they're charged, plug the battery pack back into the Cricut, then plug the Pi back in, turn it on, and let's log back in. Now, if everything just worked, we can check to see if our Mosquitto server is running, so we can return to the browser, copy this command here, systemctl is active Mosquitto, paste it in, press return, and if everything is working, we should see the word active show up before the prompt shows again. Next up, we're going to add our client program. So this is the program that will subscribe to any messages sent by our app, and it's a program that I've written in Python. So our app is the publisher. It's going to send messages to Mosquitto. Mosquitto is the broker, and then it's going to forward those messages on to any programs that subscribe. And the program that we're about to write is the subscriber. We're going to call that program control-pybot.py. So copy this command here. This is going to create the file in nano. We'll return to the prompt. We'll paste it in. Nano starts, but it's blank. So let's get the code we need to paste in. And we can find that code at this URL, github.com/gallagher/cricut-py-bot. Copy that. Open a new browser tab, paste that in, and click on this link here that says control-pybot.py. And this is all the code that we want, so start highlighting from line 1, scroll all the way to the end. If yours looks slightly different, it just means that I've updated the code since I first recorded this video, but make sure you go right to the last line, copy that, then we'll return to the terminal and paste it in. Now, it might not look like it all pasted in, but it pasted in several pages of code. So if you use the up arrow, you can scroll all the way up to the top, and there is one change that we want to make. And you're warned to do this in the code here too. So you see right after these red lines here, it says server address equals hostname.local. Well, we want to change that. We're going to change the server address to whatever the hostname is for your Raspberry Pi. If you're on campus, you can leave the .local off, but if you're having problems, you can go back in here and you can add the .local again, but make sure that your server address is the name of your Raspberry Pi. Then once you've made that change, do a Control X to get out, press Y to accept the changes, and press return again. Let's head back to our instructions document, and we've completed these changes up here where we changed the server name to our Pi's host name, and now we want to run this code. So that's the Python command that you see down here. Highlight that. It's Python space control-pybot.py. And this is going to play a startup sound for us too. So paste this in, listen up at your speaker, press return, and there is a chance that you might see this error where it says no I2C device at a particular address. If that happens, one of two things need to be done. One is make sure that your batteries are charged and they're plugged into your Cricut hat and your Cricut hat is powered up. And if that doesn't work, then just tap the reset button that's on the Cricut and that should make things work. If you try to run this again,
ready to roll. Let's go.
and ho-ho, we're up and running. So if things are working, you're not going to be returned to the prompt. Now, if you ever wanted to get back to the prompt, you could do a Control-C again, but you'll get a message that says, welcome to the Pygame community. You'll get a message that says what the server address is, and subscribing and subscribed will show up as well. The ready to roll sound will play, and we can actually try out by sending commands to the broker to send on to the program that we just started and see if that does anything. So let me show you how we can try that out. We're going to return to the browser, scroll to the area that says open a new terminal, then test write a program to publish a command to move our robot. We're actually going to first get the robot to play a sound, so highlight this command. Mosquitto_pub publishes a command to the Mosquitto server, and this is the type of command that our app will normally send. Now we're going to swap out our Pi's name for the host name that you see here, and the 0 at the end means play the MP3 sound with the name 0.mp3. So with this copied, return to the terminal, and since our Control-Pybot program is up and running in this window, we need to open another window before we can paste this command in. So let's create a new window. On the Mac, it's Command N, or you can go up under the Shell menu and select New Window. If you're using PuTTY under Windows, there should be something similar. Then log back into your Pi. I can't send this directly from my Mac because my Mac doesn't have Mosquitto software on it. But then paste this command into the prompt after you have logged into your Pi, but don't press return yet. First, you want to change the host name so that it's the name of your Pi. Then listen up and press return.
Bro, that's totally cool.
Oh, and bro, that is totally cool. And my middle school daughter and her friends all call each other bro, so apparently bro has been claimed as a gender-neutral expression. But if you want, sound 11 is you go girl. So give it a try. Just change 0 to 11, re-enter this command, and enjoy. I'll enter some other commands in here. I actually forget what some of these are.
Go set the world aflame.
So that's something that's common for Jesuit universities. My university's a Jesuit university.
Keep at it, Eagle.
And Eagle is what our mascot is. And I'm recording this around Thanksgiving, so I thought I'd put a gobble in there. So good, you can try out the other sounds, you can add your own sounds if you want to, just make sure that they're named 0.mp3 through whatever number.mp3, and they'll work. So now let's see if we can get things moving. So I'm going to highlight the command with forward in it, and you have to be a bit careful because once you start your robot moving forward, it's not going to stop until you issue a stop command or you unplug it. So here's what I'm going to do. I'm going to paste this command into the terminal, but I'm not going to press return yet. And then actually I'm going to go to my browser and I'm going to open up a plain blank Google Doc. You can use any service that you can type into. Then I'm going to copy the stop command that you see here. I'm going to paste that into my Google Doc, and I'm going to modify the command so that the host name is the name of my Raspberry Pi. Then I'll copy this, and I'm doing this because I want the stop command to be on the clipboard so that I can just paste it in and press return really quickly when I want to stop my bot. So now I'm going to return to the terminal. I'm going to change the host name in the command, the forward command I pasted in, so it's the host name of my Pi, and then I'll prepare my bot, so I'm going to hold it up. I'm actually not going to let it fly off of my desk. So you can see I'm holding it up, and I'm going to press return. And oh, the wheels start moving! Paste in the stop command that I'd copied previously, press return, and the wheels stop. Nice, your robot is working. And you can see in the window in the back here, actually there's a message that says that it's actually moving forward and it's at speed 1.0, which is full power for each wheel, and then stopping printed out when you sent your stop message. By the way, I'm so sorry. I'm recording this with the sloppiest robot build that I have lying around. I'm going to redo an assembly video where things are going to be assembled properly, so I'm sorry the wheels are wobbly. The Adafruit product is actually a very high quality product. I just slapped this together super quickly so I could get the video up. So now the final thing that we need to do is to set up a service that will load the CircuitPython program after the Mosquitto server starts when the bot is first turned on. So when we do this, we won't have to log into our bot with a terminal program. We won't need to run the CircuitPython program manually. This is going to happen automatically. You can just listen after you turn on your Raspberry Pi for the ready to roll signal to play through the speaker, and when you do that and you get your app, you'll be ready to control your robot from your app. So here's how we set this up. Find, highlight, and copy this command here, sudo nano/lib/system/pybot-mqtt-client.service. Return to the browser and paste that in. That's going to start a blank nano session, and I've already set this up, so I'm so sorry. Your screen is blank. I'm going to use the RM for remove command to delete the existing service that I've got here. Now I've got a blank screen. Now I'm with you. So the special control script that we have is actually stored in GitHub. So I'm going to highlight this URL, paste it into this tab over here. And this time you want to click on the link that says pybot-mqtt-client.service. And this is a script that can be executed by the systemd service in the Raspberry Pi, and this can be used to run certain programs in a certain order when your Pi is first started. We haven't talked about any of these commands yet, and we really don't have to worry about them. Just highlight and copy this entire script, return to the terminal, paste that into Nano. We've got our script here. Nothing needs to be changed, so we can control X, Y, press return. And next we're going to enter a command so that this script runs whenever our Raspberry Pi is started up. So we're going to highlight this command here, this sudo system control enable pybot-mqtt-client.service. With that copied, return to the terminal, paste it in, press return, and now let's make sure that everything is working. To test this, I'm going to type in sudo halt, and now I'm going to shut my Raspberry Pi down completely. So I'm going to unplug everything. I'm going to unplug the power that goes to the Cricut. I'm going to unplug the power that goes to the Raspberry Pi. Then I'm going to plug them both back in, and my Pi should boot automatically. And notice I'm not going to log in, but we should hear the ready to roll let's go sound. It'll take about 30 seconds, so I'll speed the video up. My youngest child snuck into the lab and put googly eyes on my speaker.
Ready to roll. Let's go.
And there we have it. Our bot is ready to roll. In the next video, I'll show you how you can download and use the Meal Mascaras app. But congratulations, everything's working.